In this video, we will use STAAD.Pro to design a simply supported beam carrying a UDL. We will also look at how to draw shear force diagram, bending moment diagram, and so on. In this video, we will quickly see how to design a beam. I will give the file name as exercise 2 beam. I will use a metric unit system. I am skipping the job info. I will give one of the supports at 0, 0, 0 coordinate and the other coordinate as 3, and I will draw a beam from first node to second node. So this creates my beam. I will change the view to front view. Now I have modeled a beam. Let me consider this as a simply supported beam, and now I'm supposed to give the cross section. I'm clicking on define rectangle. Let me say the depth as 460 mm and my width as 230 mm. The material as concrete. I have defined a section. I'm going to assign this particular section to this beam. So I'm using use cursor to assign method. I'm selecting this beam. Now this property is assigned to this beam. I have already given the materials here, so I can check whether the material is assigned. Yes, concrete is assigned. And I'm skipping the specifications. Let me go on to the supports. I'm creating a simply supported beam. So one end is supposed to be pinned. So I'm using cursor to assign one end as pinned, and the other end is supposed to be a roller support. So for that I'm using fixed butt condition, and a roller has releases in all the moments as well as in the direction of length of the beam. So I'm releasing all these restraints and I'm assigning this support to the other end. Now I'm coming to loads. I'm giving a load case. Within the load case I'm going to give load items. So I will include the entire self weight. I will give a member load, say example 5 kilonewton per meter for the entire length of the beam. Here D1, D2, D3 are all self-explanatory. D1 is the start distance of the UDL and D2 is the ending distance of the UDL and D3 is the offset. If I leave all these as 0, then it means that the load will be from start to end of the beam exactly over the center line. So this self weight will be assumed to all the members, and this UDL I am assigning to this selected beam. There are 4 different assignment methods. You can use your convenient method to assign, say for example, property or material or support or loading and so on. Next I'm coming to analysis. I'm giving perform analysis command, and then I'm going to the concrete design. Let me choose IS456 and I'm defining a parameter. These things are self-explanatory, and if you click on any particular design parameter, its explanation is also displayed here. So FC is the compressive strength of concrete. Let me give this as 20,000 or 20 megapascal, and I'm assigning this FC 20,000 to all the beams, and I'm asking to design this as a beam. So before performing design, all these parameters has to be mentioned. Now I'm going to run the analysis. After the analysis is successfully closed, I will view my output file. So this is my output file, and here there are some warnings and messages. This warning is displayed because at both the ends the MX is released. So The STAAD automatically adds a weak spring to it. Warnings can be ignored, but errors must not be ignored. And when I scroll down, you can see the AST required at various sections and what is the AST provided as per IS 456. And here you can see what is the code used, what is the concrete used, steel for main reinforcement and steel for secondary reinforcement. And the stirrups are two-legged 8-dia stirrups at 300 mm center to center. So this gives the design of beam. If we want to check about the shear force diagram, bending moment diagram and deflections and so on, we can go to post processing, and I will include the only load case that is available right now. I can maximize this, and I will go to the beam results. By default it displays the bending moment diagram. If I want to look at the shear force diagram, I can do Fy. Here you can see the coordinate, global coordinates. Y is the vertical direction, so in this direction I am weaving the shear force, and the moment will be along z about z axis. So mz gives my bending moment diagram. If you want, you can check the values also. Click on annotate, beam results, maximum bending moment, and click on annotate, and it gives maximum bending moment as 8.429 kilonewton meters. And for shear force, to enable shear force, click on annotate and beam results, and at the ends you can see the shear force is 11.239 kilonewtons. You can manually check the values of these things. The shear force is supposed to be WL by 2 and the bending moment is supposed to be WL square by 8. You can also check for deflection. It's 5 by 384 WL power 4 by 3 EI. You can check these things manually. When using softwares, you are not supposed to rely on them blindly. You can have some small checks. For example, you know what is the maximum deflection for a simply supported beam carrying UDL. You can use that formula to check the value obtained here. You can also check what is the maximum bending moment value. Okay, our next video will be on design of columns.